and his name, as you already know, Srijit Mukherjee, and he's not that filmmaker, right? So he did a very peculiar thing. He peculiar in the sense that he graduated in statistics, both bachelor's and master's from the Indian Statistical Institute, and then he thought electrical engineering will be a good bet to do his PhD. And so it's a unique combination nonetheless. And and Srijit is working in a very important area, combining the deep learning, its explainability, and the medical imaging, brain imaging, I guess, to be very specific. And the day I requested him to give a talk in this winter school, he's immediately agreed. I think within half an hour, he came back with a fantastic topic, hands-on, to build up a BabyGPT. I know Srijit is a very good speaker. I believe he has a YouTube channel as well, and he loves to teach. He loves to talk and he loves to teach. So I'm sure all of us will enjoy today's session. And over to you, Srijit.
Yeah, thank you for the introduction, Professor Mukherjee and Dr. Banerjee. First of all, without Professor Mukherjee's help, I wouldn't have been able to transition from statistics to, I would say, electrical engineering, but I do not know anything about electrical engineering, to be honest. I just know I came to Penn State and did an undergrad course in computer vision because I'm working with imaging. I did a graduate course and then started my research. So if you consider like computer vision, I think it's a part of electrical engineering, image processing. So that's the only knowledge I have, nothing more than that. And also I want to thank Shankar Shonshil for helping me understand what he has already taught and shared so that I can assume those fundamentals rather the basics of what he has taught. Today, let me share my screen. So this transition from statistics to electrical engineering, this is kind of really fun in the sense. Just give me a minute. So I have been questioning what was the use of statistics, what was the use of like what is the difference, and a lot of commentary has been written on this in research. Great people have talked about that issue. Yesterday, actually, why I brought up this issue again. Yesterday, if you see, I think MIT, so there is a professor named Alexander Amini. So they run a course called Introduction to Deep Learning. Please feel free to watch that. It's an excellent course. It has been running for a few years, and in that there's a small there's a one tutorial named Modern Era of Statistics. I really didn't expect like one entire 2 hours lecture on amidst the like LLMs and all this deep learning stuff, a single topic on modern era of statistics. I was curious and to see what was there because I can at least understand something. And then I went into that. It was pretty interesting in the sense that whatever the statistics I have learned at ISI, I mean, that thing was not there, but interesting new stuff has come up. Like you probably have heard of double descent. So let me explain you what is double descent in brief, which is nowhere related to this, but I think it should be important for your future if you want to carry on in this deep learning. So double descent phenomenon is, let's say you have you have been we have been doing and working with large models, right? Large language models. So large means number of parameters is large. So what they've observed is that, let me just randomly draw here, that you expect that the training accuracy, training loss and the validation loss to be decreasing with every iteration, rather epochs, right? I'm sure you must have done this in the past 2 months. So what double descent? This is descent, right? this is descending to the loss is descending to zero. So what double descent says that uh, if you make the model larger and larger, there's a chance of overfitting, right? And I am sure all these things are talked about. So what double descent says is that if you make a model very large enough, so initially you see a dip, and but again there is a local overfitting. But again, if the model is made sufficiently large, it again goes to zero like this. So there's a one descent and then goes up, and then again another descent. And it has shown, like researchers have proved empirically, I'm not sure mathematically or not, that this double descent phenomenon makes or leads to better generalization to unseen data set. It learns better. It has some other boundary cases and nuances, which I will, this is just for um, a demonstration purpose, that what is double descent, and just wanted to talk about that. Yeah, probably there is some interesting probability theory attached with it. Anyways, coming back to what we will discuss today, I will discuss this 7 points. First of all, I will give an explanation, or a non-code based explanation to how you can at least build a baby GPT. Baby GPT means the number of parameters is not so large, but it's like a boiled down version, a small version that you can run right now. I will show you right now running it online. Uh, and that will help. That's kind of a toy example to help, like, to understand what's happening inside. This will be easier because I guess you remember the ideas of transformers, but I will again revise those things and stuff. Then I will show you the baby GPT in action. So I will use two texts. So I am very comfortable in two languages, English and Bengali. I have I am not so comfortable in Hindi, but I cannot read so smoothly, so I have not taken that. So I have taken two texts. One is the Constitution of India, that text, entire text, and the second text is the it's a story by Satyajit Ray. His birthday was on 2nd May. So it's an honor to him. The name of the story is Royal Bengal Rohosho. So we will be using these two stories. The second Bengali text is chosen to show you that you can actually apply this method to any language you want. French, any Indian dialect, or anything, whatever you want to do. And I will use these two texts, and I will show you the same thing that is happening and train it. And I will then, the next part will be explaining the code, what's happening step by step, and showing it online, like running it. And finally, I will tell you the inspiration and references that helped me build this. And I want to thank all the participants who have joined here for their dedication for the 2 months, and probably this towards the end talk at night. Okay, so let's understand what we will do in what do we exactly want to achieve in ChatGPT, rather the GPT thing. What do we want? So we are giving an input, like let's say like this. As you can see, I asked ChatGPT 3.5 that help me study vocabulary, write a sentence for me to fill in the blank, and I will try to pick the correct option. And it gave me an answer. Now, all these things look so smart enough from ChatGPT's side, but essentially it's nothing but you're giving an input text and you're getting an output text. And text is nothing but set of characters. So H is a character, E is a character, L is a character. So if you want to understand from the very fundamentals, we are inputting into the model some characters x1, x2, xn, and we are getting some output characters. Let's assume it's kind of a reply to that, so we call it xn plus 1, xn plus 2. So why I said n plus 1, n plus 2 is it means the time. It's like the next k characters. So if you want to write it a bit mathematically, because mathematics is extremely important to understand, if you want to code it from scratch, otherwise you can just think as we are giving a sequence of characters. X1 is, let's say, H, X2 is E, then L, then P, and then output is, let's say here it's A, then B, then S, and then goes on. This is output, and this is this input. So we essentially want this to happen. right? All of you okay with this? So I do one thing. So there is an emoji button. Can all of you look, uh, see that? So you can just give a thumbs up in that emoji button. Let me do it for you once. That it will help me to communicate with you. Okay, Fazil got it. I just want to make sure if everyone gets it. So we have Avinav, Abhishek, Anisha, Anithak, Orlando, CSI Kolkata, Debashish, Te, Dharas, Sri Panda, Deepti, Prashad Mukherjee, Mohua, Dr. Jyoti, Dr. Mohua, Fazil, George, Ipshita, Jaya Pradha, Mrs. Denisha, Shoikot, Sharkar, Shojol Mitro, Shankorshan, Shil, Shantanam, Lakshmi, Srimanto, and Shubhanil. Can all of you look into this, like, or at least the participants of the workshop? Can all of you get this emoji? Yes or no? Can you please kindly say yes? Okay. Uh, thank you, thank you. So yeah, if you cannot, then please write yes when I ask yes in whether you understood or not. It will help me to communicate because we are not seeing each other live, right? So I hope all of you understood that what we exactly want to do. We want to input a sequence of characters, let's say. We are taking the simplest thing possible in the world, sequence of characters, and it's outputting a sequence of characters. We are not encapsulating the meaning of the word. For example, there is one thing I'm sure it must have been taught, is that, for example, if there is a word help and helped, in the same sentence, these two words has meaning to very close to each other. So the modern GPT and things make sure that the meanings are really close by. But I am not considering any of these things here. Okay, I am just doing it character by character, and two character A and B has no individual meaning, right? So this is something we want to make sure before we make the model. So all of you understood that we are doing character by character input into the model, and we're expecting character by character output. This is how we are seeing the model. All of you understood this? Can I see a thumbs up? Okay, great. Super. So what's next? So what exactly we want to do? I just want to write down the whole thing. So we are inputting x1, x2, x3. So you can say xi are nothing but the character set. Let's say in this case A, B, C, D, all these things. So this set, this is called, from where the each characters are coming, is called a vocabulary. It's just same, right? Vocabulary. Like if there, for example, in the Constitution, you will see that there are 1, 2, 3, 4. So those are also characters. We are considering them as characters. We are not considering any relationship between them. For example, 1 plus 1 is equal to 2. We are not considering that. We are just considering them as strings, as characters. So we are getting this input and we are getting output. That's it. So this is what we want to do. We have a neural network. We will talk about what this neural network is all about, but we want to input a sequence of characters and we output a sequence of characters. Okay, now what's next? The next question is that, given that we have a model, how do we design the entire learning process from scratch, right? So I took this Wikipedia text of Satyajit Ray, and this is, let's say, the training data. So we, of course, I'm sure you must be knowing about the idea of training data, test data. So we have this training data. So now the question is that what is the X? So I will be revisiting the whole deep learning procedure one by one because it's important for you to understand, because we are doing everything from scratch. So this is the training data or data. So how do we divide the data in training, test? How do we divide the data into what is the prediction, what is the features, what are the features and what is the response variable? What is the Y and what is the X? You understand? Without knowing that, we will never be able to build a proper model. And so that's why it's very important to understand how is X, how is the Y, and what is the function we need to define between it. So we need to know what is X and Y. We need to know how to train it, right? That is very important, because training is a tricky thing when you're doing over. For example, I will be taking the data set of size 1 million characters. So it's huge. So how to train it efficiently? And this is the problem of the model. Like, this is a research where it's going, and I'm sure the hardware industry, you must be, if you follow the news of Intel, so they are all trying to build a, so there's a whole architecture that we'll do in computer, whatever the current architecture of the system, the whatever the hardware is, it's called von Neumann architecture, if I'm not wrong. Um, so they are all transcending. So this is not so suitable for parallel computation. Okay, so I'm not sure if I'm totally correct, but this is what I heard. And therefore, the new generation architecture that is going towards is called neuromorphic computing and neuromorphic architecture, which is different kind of thing. So that's why training is very important. Why I mentioned this is the training, proper training with efficient memory is very, computation is very important. And the third is, after training, how do we infer? Like, if I input a prompt like this, how exactly it is actually doing the next prompt, like giving the output. So these are the three things we'll be discussing from scratch. Okay. Um, any question? Any question? Did you understand till this point of time? Yes. Give a thumbs up. Okay, Simantas, give a thumbs up. Whatever. What about others? All of you understood it? Any questions? Okay. Okay. So now, naturally, since we'll be discussing this from scratch, let me revisit the deep learning process very briefly, over 5 minutes. And I have made it colorful so that you can keep your eyes open. So you're inputting in X data. Let's say whatever the features is in, let's say if you're doing a image classification, then X is the image, single image. This intermediate connective thing, it's neural network, which has certain weights, which are parameters in statistical language. In machine learning community, it's weights. And we are outputting a function. This is a function. We are getting this f of x comma w, which is kind of the predicted, they call it predicted y hat. And then based on this predicted y hat and y, we are creating a loss function to see how close they are, which is a function of the w weights again. Now this is for a single image. So it's for a single image, xi, I, yi, and we get a single loss function. Now this loss is summed over all the data sets. The mean is taken, and then that is minimized step by step to get the W star optimum, like weights or parameters, the best parameter values or best weight values. And hence a new function is formed. And based on that, when a new data is input, x new image, then the predicted output. I am assuming the predicted output is, I mean, there's no assumption here. I'm not talking anything about it. It's either logits or probabilities, or the either the soft classification or hard classification. I mean, so either you give the probability or you give the label. So this is the deep learning process, the basic process of how the training. So we discuss our features. X is the feature, response is the y, weights is this w, model is this f of x, loss is this, and the inference is how this inference is done. So this is the entire process of deep learning with the corresponding keywords I have mentioned. All of you understood this? Any new concepts? Any doubt out here? Feel free to ask, because yeah, I mean, yeah, when I was a master student or incoming PhD, I didn't know all of this in great detail. So I do not expect all of you to know either. So feel free to ask. Any questions, any doubts? Okay. So now something needs to be told about training. Again, this is very detailed because we are doing something from scratch. Now you must have heard about gradient descent. So what is gradient descent? It is nothing but a function is there, you want to find the minimum of the function, so you follow the gradient towards the minimum. Like there's a hill, there's a minimum of the hill, the valley, so you follow towards, just like you walk down the hill to the valley, just like that the model is made in such a way that it walks down the gradient towards the mean, towards the minimum of the loss, to optimize the where the minimum is taking place, like this. Now there's a bit of a problem. If you remember, we this sentence that the sum of the loss, the mean of the loss is taken. What it means is that for each of the image, at every step, the loss is calculated, it's averaged out, right? For n data set, let's say, in the training. And that gives the gradient of the entire loss function, right? Because the loss is, let's say, summation of all the individual image loss. And when you take the gradient, delta, so delta goes inside. So because delta is an additive function, right? Uh, the derivative, and hence the summation of all the derivatives happens. Now this is if there is a lot of training data, understand, let's say you are running it for 100 200 epochs or 1500 epochs. There's a trend to do more number of epochs because it generalizes better. And if there are million data sets, it's like really hard. Okay, so it takes a lot of time. So what they came up with is called stochastic gradient descent, where instead of taking a sum, they took randomly one element out of them, uh, out of the training data set, and just calculate the loss, and then kept on adding. Now why that worked? Because the average value is the same. Because you see this, so this purple thing is nothing but the stochastic gradient descent. The blue thing is the batch gradient descent. Batch is nothing but the entire data set, entire training data set. So if you see, the average is kind of the same. There's an average. It's on average, it's going towards, because it's a randomly taken thing. If you take the expected value, it will be the same as the normal gradient descent when you average it out. But you see, it takes a lot of time to converge. Okay, naturally that makes sense. So to balance this, we do something called mini-batch gradient descent. What's done is that a subset of the data set is taken, a random subset. So essentially, the training data set is divided into, let's say, batches of 32, let's say. And for each, the gradient is calculated until all of them are done. And so for each, the gradient is calculated, the loss function is updated for each of the two stuff. It's not done randomly. Like after this 32, it is made sure that all the training data set is covered. So first 32, then the rest of the another random 32, till you get the last, you cover the entire training data set. Now once this whole process is done, it's called one epoch. Okay, so this is the entire epoch. You take a batch size of 32, calculate the gradient, find the updated weights, then again take a random next 32 elements of the remaining one, calculate the gradient, calculate the updated weights, till you cover the entire training data set. Now after this, all these batches, this is called a mini batch, all these batches are calculated to cover up the entire training data set. That's one epoch, that's one iteration. Okay, and now this iteration happens for, let's say, 500 epochs. And this is what the mini batch gradient descent is. And you can understand, it's kind of, there's a stochastic nature to it, and there is also a bit of actual gradient descent nature to it. And this two together is the green part, which is a bit random, but it's less random than the stochastic gradient descent, and it's more efficient than the normal gradient descent. So therefore, this is important because we will be introducing this into the whole code while we write from scratch. All of you understood this? Yes or no? Give a thumbs up if you understood. This is a very important understanding idea. Okay, any what about others? So I will call out the names. Can all the participants, I don't want to call out professors' names, can all the participants out here raise their hands, like who are attending the workshop? Okay, Fazil, Aurobindo, Srimonto, George, Anisha, Abhishek, Ipshita, Debashish De. Okay. So yeah, so I'm asking this to like participants mostly, that I hope all of you understood this, right? This is very important, guys. If you have any doubt, feel free to ask me. Any doubt you have? Yes or no? You can unmute yourself. Any question, any doubt regarding this?
So which one is better, in stochastic or mini batch or?
Mini batch gradient descent, because it's a mixture of efficiency, like stochastic gradient descent, but it takes a lot of time, and also a bit of batch gradient descent. It's a mixture of that. So mini batch, the green one is the best. That's how it is done.
So during this process of optimization, we only use this mini batch mostly.
Yes, yes. We only use this, not mostly. Like we only
Only.
use, yeah,
Okay.
batch best.
Thank you.
Sure, sure. Any other question? Okay. Okay, so I hope everyone is on the same page with me. Now we will go into the GPT making procedure step by step. Now, again, what is the X and Y? We didn't discuss it, right? What is the X and Y? How is the training data and test data curated for this learning procedure? Let's say we take a data set, and let's say we took the Satyajit Ray's Wikipedia page. So what we do is that we took the data set. This is very important. This is a part of data pre-processing. The first step is this, that we want to convert the text into numbers. Otherwise, computers cannot understand, right? We want to do this. How do we do this? In this case, we do this in a very simple way. So we first convert this. So we take the entire text. Now the entire text has very unique characters, right? Like if you take the entire English language, all the characters, the number of characters is 26 into 2. 26 for the smaller letters and 26 for the big, like capital letters. So that is called a vocabulary. That means a unique set of characters. And from the unique set of characters, what we do is that we order it, in, let's say, in the lexicographic order, the alphabetical order, and or you can order it any other way. It doesn't matter. And we assign number to its corresponding to its index. Let's say you have A, B, C, D like this. We assign it 1, 2, 3, 4. In Python, it starts from 0, 1, 2, 3, 4 like this. Okay. So just the index. So it's like xi is assigned I. The ith element is assigned the value I. This is the character. The ith character in the vocabulary is assigned I. So this process is called, so this assignment of numbers is called encoding. And it's kind of the function which takes the vocabulary to the assignment of numbers. And if you have the assignments and you go to the vocabulary, it's called decoding. Okay. So it's like F and F inverse. Yeah, any question? Dr. Muhua? Okay. Yeah, Abhishek, do you have any question? Any question in this, guys? Okay. So now, what we will do, will it be possible, Dr. Pal, to mute? I know probably it has been unmuted. Oh. Can the host do anything? Yeah, thank you. So we want to, so this is how we assign the numbers, integers, or rather, we take the text, we convert it into vocabulary, the unique set of characters, we assign integers by the index of each of the vocabulary, and then transform the text back into numbers. So all of you understood this pre-processing of the data set. This is the pre-processing part. Yes or no? Can you give a thumbs up? Did you understand this pre-processing part? So this is what is done in this case. Okay, in this case. Now this is how the data set is converted. The text is converted into numbers, basic numbers. Now we want to talk about the next part. What is the next part? The next part is How is the training data and test data curated? So training data is curated in a very basic way. So the first, let's say if you're taking the Constitution of India, that entire text, the first 80% is taken as first 90% is taken as a training, and the first 90% characters. Training. And
So what
last,
about the blank spaces?
yeah, so very good question. So everything is converted into characters. So there is an order. Everything is converted into characters. So
And all punctuation marks also.
yeah, everything. Yeah, thank you for the question. So everything is converted into these indices. Now if you sort, there's a function called sort in Python. So if you sort it wherever the punctuation mark and all these blank spaces are, it's just converted into the corresponding index. So the first 90% characters are for training, and the rest 10% are taken for testing or validation, let's say. This is how the whole training and testing, or rather training and validation works. So now the question is that what is the X and Y? And that what we will talk about in the next. And I believe that this is the most important part of understanding the model and the whole process. So please be careful in this small aspect, because this is where you will see that I don't know how many of you have used ChatGPT regularly, but this is something very important. So if you talk to ChatGPT or any other LLM, you will see that, let's say you start a conversation, you talk to the LLM for, let's say, 5 minutes, and then you write down something that was related to the initial text that you have started with. You will see that it has forgotten what you have written before. Okay. So why is this happening? This is happening because of something called context size or block size or context length. And the recent papers are working on stuff that is called infinite context length. So what is happening here is that the training is done based on a certain length of characters. We cannot take infinite length. What would have been the ideal case? Let's say there are n characters for training. Okay. Now, first question is, how is the X and Y selected? The X and Y should have been ideally is that you take X1, you predict X2. You take X1, X2, you predict X3. You take X1, X2, X3, you predict X4. You take X1, X2, X3, X4, you predict X5. Dot dot dot. You take X1, X2, X3, X to the power Xn minus 1, you predict Xn. This should be the ideal amount of computations, right? Now, first of all, if there are million characters, it's very hard to keep a track of this. So its memory efficient is gone down, right? So that's the problem. We cannot take this large size, because understand, you want to train on a basic, like each one of us will have different training data sets. So, and it can vary a lot. Imagine the whole, like a model being trained on the entire web information. It cannot do this, right? It number of characters, it will just break down. It cannot even compute this thing. So something needs to be done. So ideally, this should be the X and this should be the Y. The Y is the next character, right? Ideally, this is how it should be done. But there are two issues. Number one is that the amount of information here, like if you do it one by one, it will take a lot of time. So two things need to be done. And that's why I think this is the success of transformers. If you see the other architectures before, LSTM or recurrent neural networks, which is LSTM, or LSTM is based on that only. It's a kind of a series computation. Okay. It's one after another. No, a series circuit, right? But I think the success of transformers from a computational point of view, I do not think attention is the key. Like the idea of attention, because it was before, but I think the whole idea of parallel computation. So there is the whole computation is done in such a way that it's a parallel competition going on, not a series connection, and we will discuss about it. And that's where it is, I think it is the most valuable in terms of research contribution, parallel computation. That's why people have adopted it so worldwide, because of the efficient computation structure. And we'll discuss how it's happening. So we want to have, there are two things. One is parallel computation. The other thing is, um, the size of training, how to train. So ideally, I am repeating once again. Ideally, you take a sequence and then you take the next one as a predictor, right? And these are all numbers. Xi's are all numbers. Let's say now. So you have a sequence and you're predicting the next word, next character. So it's kind of, um, now these are numbers. It's numbers, but these numbers have no sense. These numbers are kind of characters. Okay, so uh, well, not characters. Ideally, we will see how it is, but each of them is a. We are not using these numbers in a very specific way. We'll talk about this. So we are not, what I'm meaning is that it's not a, you're predicting the logits, okay, not these numbers. That's what I mean. Okay, you're not predicting the indices like as numbers. You see, this is, let's say, 23. You're not predicting 23. You're predicting the logit, which is giving the index 23. So both are different things. So yes, so logistic regression is a regression problem. It's not a classification problem. Okay, this is a, well, this is a basic thing where people get confused because you're predicting the probabilities, right? So I am not trying to say, so I was initially thinking of telling you guys that it's not a regression problem, but logistic regression is actually a regression problem. So what I mean is that it's not predicting number 23, but it's predicting the index 23, okay, by computing its logit. Okay, so we will talk about this size of training and context length next. So before I move over to that aspect, all of you understood this idea? Give a thumbs up if you understood what I am trying to share here. Did you understand this idea? How the ideal training should be? Give a thumbs up if you have. If not, please tell me. Any question?
Sir, can you just repeat this part once more?
Yeah, please tell me which part, Aisha.
Sir, the context, the length you just told right now.
Yeah, I have not talked about context length. What I have talked about is that what would have been the ideal training scenario. Like ideally, you would give a sequence each and every, like from the beginning, you would give till certain length of sequence. And so, okay, let me explain once again. So ideally, if you take this text, you want to give like S, and then you want to predict A. You want to give SA and you want to predict T. You want to give a SAT and you want to predict Y. Till you want to do entire thing and then you want to predict the A of the award. Then you include A and take the entire thing. Okay. So you see you see what I mean. What would have been the ideal case? That's what I'm trying to make you understand. This is not, so once you understand the ideal case, you will understand how big computationally it is. So Aisha, did you understand?
Yes, sir.
Sure.
Yes.
Okay. So ideally, this would be like we would take a large A from the beginning. You would ideally take everything out there and then predict the next character. Okay. But this is a problem, you know that, because of the size. So what we do is something we introduce the idea of context length or block size. So what is that? And how do we do parallel computation? So what we do is, this is the X and the Y in, so understand this very carefully. We do it using block size. Let's say we take a block size of 4. So we have x1, x2, x3, x4. Okay. And we are taking x2, x3, x4, x5. So this is the Y we are predicting, and this is the X. Now understand that So there's a small confusion people have, which I will talk about, but this is how it's done. So x1 is giving, we want to see what is the next character after prediction after x1. For x1, x2, we are seeing it's x3. For x1, x2, x3, we are seeing x4. We are predicting x4. So we are taking this and this. We are taking this two and predicting this one. Okay, so this is the basic idea. And we are doing the essential same thing, but we are reducing the size. So we take the first 4 characters and we predict each one of the next characters based on the, so again, I'm repeating once again. We take x1, we predict x2, we take x1, x2, we predict x3. So we take x1, x2, x3, we predict x4. We take x1, x2, x4, we take a predicting x5. Now we are not doing x1, x2, x3, x4, x5, and x6. So we are missing this out. Okay. And that's where the idea of block size comes up. Now we are taking all possible 4 length block sizes consecutive. Okay. And then predicting the next ones correspondingly. So this is the y and this is the x. Now you may ask, like, why it is done like this individually, and why is done like a vector? Why is a vector instead of the individual y is like x2, x3, x4, x5? And that's where the whole idea of parallel computation comes up. So did you understand this idea of context length? So to repeat, we are not taking x2, x3, x4, x5. We are not taking this for prediction of x6. We're taking at most a size of block, a block of size 4, and we are doing it all over again, all over the training data set and predicting the next part. So all of you understood this? Yes or no? Give a thumbs up or please ask me out if you didn't. Any question? Did you understand? Thumbs up, no thumbs up? Okay. What about Aisha and others? Okay. So we are taking.
Excuse me, sir.
Yes, please, Dharasri.
Sir, we are taking a block of 4.
Yes.
That means if we have words of more than 4 or 5 or 6 letters, then how it will predict?
No, so do not think as words, just think of characters, okay?
Okay.
So yeah, that's the initial starting assumption we made. So if you have a word, let's say my name is Srijit Mukherjee. So we are considering my name and there's a space in between. So that is considered as another character. Okay.
Okay.
So all
Okay.
these things, we are doing character by character. So we are taking 4 characters. We are translating over sequentially over the entire training data set, one by one. So this is the, let's say, a block size, and you're translating over one by one. You're moving over all the characters one by one. Okay. And then predicting the next one, predicting the next one. So this is how the block size is coming up. Okay. We are not taking, ideally, we'd have taken all block sizes, 1 block size, 2 block size, 3 block size, but we are taking up to the 4 block sizes, not more than that. Okay. This is where the new competition comes up. It makes it lesser. But where is the parallel competition comes up? The parallel competition comes up in this aspect that we are doing this X and Y together. Okay. And if you have done the transformers, did you hear about the word mask? Did you hear about the word mask, M-A-S-K, while learning transformers? Yes or no? Did you hear about it? Give a thumbs up. Did you remember? Yeah. Okay. So there's something we will discuss about in mask in the transformer. Okay. So mask is nothing but it's making sure. So there's a problem when you are. So understand, this is the training. This is the X, and this is the Y. So now we want to make sure that you're using this for x1 for predicting x2. You want to use x1, x2 for predicting x3. You want to use x1, x2, x3 for predicting x4, right? You want to use x1, x2, x4 for predicting x5. So there is a kind of diagonal aspect. For example, you will not use x1 and x4 to predict x3, right? So there is a kind of a triangular thing that happens, so that the sequence, the ordering of the learning, that so that since we are taking like both vector wise, we are taking x and y vector wise, there's a masking that should happen. The masking makes sure that you are not using the future word for predicting the previous word, or future character to predict the previous character. So this is why the mask is used, and that's where, so you see that parallel computation means you're not doing individually x2, x3, x4, x5 computation and adding it up, but you're doing a parallel computation of x1, x2, x3, x4, and x2, x3, x4, x5. And that for parallel 4 block size of 4 computation, you need to have this fact that the future, because you're using x5, right? But you're using, let's say, x1, x2 to predict x3, but x5 is present in a data set. So you have to do a certain kind of mask so that this x5 is not used for learning the relationship between x1, x2, and x3. And that is where the mask is used in the whole training and the model. And this is an important aspect. This is the idea of parallel computation that is happening. Okay. And this is the most important aspect, I believe, apart from this block size and parallel computation. Okay. And probably you have remembered this from the transformer block. So all of you understood this, yes or no? Give a thumbs up. Did you understand the idea? Any question? Okay. Okay. Now this context length is done. Model, it's just nothing. We will talk about it. Now loss function is nothing but, now based on this parallel computation, we are finding the logits out of each and every single block, right? Each and every single element, the entire vocabulary. Over the entire vocabulary, we are finding out the logits. We'll see how we are doing it. We will see how we're doing it. But over the entire vocabulary, we are finding out the logits, right? We will see how the model makes it. And then the loss is added. We have the batch size of 32, let's say. And we have talked about how the batch size is done here. And you will see in the code right after it. And then the training happens. Any question? Any question? Any question till this point of time? So these are the few aspects that you need to remember while understanding what's exactly happens in the, sorry. Okay. Now, how is, so after the whole model is trained, how is the entire inference drawing? How is the ChatGPT replying? That's called inference. In statistics, who are from statistics background, inference is considered, in statistics, both training and testing is called inference, but in machine learning, like testing is called inference, or evaluation, like no inference. There is no training involved, so just a linguistic change out here. So how it's done? It's simple that if you have an x, so let's say you give the initial, let's say SAT or Y of Satyajit Ray into this model. So essentially it's taking, let's say 23, 45, 36, 99 into the model, and the model predicts logits, right? From the logit, it takes in or gives a new character, let's say 0 for A, right? So that means A. Rather, it takes in the 0 into the model, and then 23, 45, 36, 99 is there. Now remember, and 0 is done, given. Now remember, the block size is of 4. So it cannot take the 23. It should take this last 4. And then it predicts the next word, next character. Let's say then it predicts J, or let's call it J. I forgot. I do not know the number. Probably it's 11 or 10. So J. Then it gets attached to it. Okay. So, or let's say it gets attached to it and we get 23, 45, 36, 99, 0, and 10. Again, it takes the last 4, and using that, it gives output, the prediction. Let's say again A, right? And again, it gets on adding, it's called concatenation. It's get concatenated to the initial IDs, and then it's returns one after another. Remember, this block size is very important. This context size is very important. It's not using the entire like all the data set to to infer. Okay, so it's kind of using the best possible case of the each step to predict the next one. Okay, so this is how it's done. All of you understood it? Yes or no? Give a thumbs up. How is this inference process done? How is this generation done? Yes or no? Give a thumbs up if you understood. If not, please ask me a question.
Sir, please repeat it again.
Sure. So, what did you need to understand, Thuristry?
About that block size.
Did you understand the previous blocks in this discussion, Thuristry?
Yes, yes, sir. Yes, sir.
Okay, let me
Okay.
explain it once again. So, let's say you give SATY in the as X in the model. The model is trained. The model gives output probabilities, right, of the entire vocabulary, and it gives that the best probability. The highest probability corresponds to the character A, which has the index or the number 0. So it gives the best probability, the maximum probability happens at 0 for the number 0, the index 0. Now what you do is that you get the prediction, right? Now you take this prediction and attach. Now let's say you have told the model that I want to generate the next 34 characters. What will be it? Now how are this next 34 characters generated? So the first character is 0. It has predicted 0, right? Now it takes this 0 and concatenate into this initial prompt or the text that you have given. So now it becomes 23, 45, 36, 99, and 0, right? Now remember, the model cannot take input for large than size 4 because of the block size or context length. So it takes this initial 3 and this new 0 as a new input and put that into the entire model, right? And it outputs the next character, that is J or 10. So this is put and we get the 10. And then again, it is attached to this whole index, the string. So it becomes 23, 45, 36, 99, 0, 10. Now the last 4 are taken into the model, are input in the model. And then the next prediction is done, which is again A. And this carries on till it generates the next 34 characters. Did you understand Thuristry and others?
Yes, sir. Yes, sir. It's clear
Great.
now.
What about others? Any question? Did you understand? Give a thumbs up if you understood. Fazil understood. Srimonta understood. What about others? Anisha, Srijit, George. Great. Great. Super. So this is how the inference is done. So now all the non-code aspect is done. Okay. And assuming that you have learned transformers, you must be knowing about what kind of LLM or GPT model is. I do not know if it's done or not, but let me explain to you what the GPT model is. So GPT model is nothing but, remember, in transformer block, there's something called cross attention. Let's essentially transformer is being done for translation. Let's say you're trying to convert English into French language. So there needs to be there needs to be an attention or kind of understanding English language, which itself needs some attention to each of the characters or words, right? French needs a self-attention, which itself needs understanding of each of the words and characters relationship. And there needs to be an attention and cross relationship between each of the language. So there are 3 different kind of stuff. There is each self-attention of both of the language and a relationship attention of each of both the language. So, but GPT model is nothing but the relationship of only one language, right? As of now, we are doing that. There can be other things too. So therefore, the goal is we are predicting the same language. We are not trying to understand any other language. So therefore, it needs to reduce it down. And if you see, it's nothing but a subset of the entire transformer architecture. Okay. Now this architecture, understanding this architecture, I think you have done enough about understanding the architecture. But what I think, as you implementing this or applying this architectures or future LLMs from scratch, or at least loading the model from Hugging Face and understanding what is doing what, you should know that rather, if you want to replicate, if you're a researcher, you want to replicate a new architecture from scratch, right? Let's say you do not want this dropout. How do you remove it? You have to actually write the architecture from scratch. So I will try to actually show you that how can you build an architecture from scratch. This architecture, and I have written a long, I am planning to make a tutorial, and in fact, I made a tutorial on LinkedIn, and I will show it to you. Of how do you think about building architecture from scratch? How do you define individual Python classes? What is the optimum number of classes you should define? And all these things comes, are very important. You should know each and every one of you. And I will try to discuss a part of it. Of course, everything is not possible. And I will give you tutorials that you can refer to after this talk. Now, as I've told you, there are 5 fundamental steps in coding, right? First is the data preprocessing, that transformation into text, to numbers, vocabulary, and then encoding, decoding this thing. Then the training, the design. In statistical language, called design of experiment. So we want to understand the design, the training part 1. And then we want to do the model definition, how the model is defined, building the model class in PyTorch. And then the optimization, that how it's optimized by batch, and all these things, and gradient descent. And all these are very generic things. Training 1 and training, the step 2 and 4 are very generic. The step 1 is unique to this problem. The step 3 is also unique to this problem. And step 4 is also unique to this problem. 5 is also unique to this problem. So we will understand each one of this step by step from scratch. Okay. Now let's understand data preprocessing. Now what I have done is that I have taken down codes, and now I will explain to you what this code does. Okay, let's do this thing. Let me first show you the code and how it's done, okay, and how it's running. And I will train it. I'll leave it to training, and then we will come back here again. Okay. So everyone on the same page as of with me right now, give a thumbs up, yes or no, or write a comment box in the comment box, yes. Can we give a thumbs up? I want to understand each and every one of you should be on the same page as mine. Otherwise, we cannot proceed. All the participants here. Very good. Thank you, guys. Thank you. Oh, superb. So let's now go to the final code. So this is the final code. So now I have taken 2 text file, as you can see. One is COI, Constitution of India, and Ray is 33, both of the text. And I will show you how things are happening right away, and I will send it to training. So first, what we are doing, we are loading the library. It's already loaded. Now we are doing the data preprocessing. As you can see, it's changing. We will explain it step by step while it runs. We will come back to this PDF and understand that this is nothing but transforming text into numbers and numbers into text, encoding and decoding, that function we have discussed. So it's run. And then this training thing. Okay. So this training is nothing but, you see this, we will talk about this train test plate, the block size, that means the context length, then the batch size, how to get the batch. This is very important, how to get the batch. Like why batch size is important and you should define it differently is this, that in one epoch, you must make sure the model has learned over the entire text data set, right? So when you're taking a batches, you must make sure the batch size in one epoch, all the union of all the batch sizes should cover the learning over the entire training data set. how do you make sure that? By a simple for loop, but you need to understand that. Otherwise, you will never understand how what process of deep learning is happening. Next comes the estimation definition. This is not an estimation definition per se, but this is something done for memory efficiency. And this is important because I do not know if you know about dropout or something, but when there's something called dropout, it randomly picks up, removes neurons, right, and make it goes to zero. It's done for regularization. Now, you want that during the training and testing, whatever the dropout is used in the training, you should use the same dropout in testing, right? And this model evalve and model train make sure that it doesn't give different dropouts of training and testing. So therefore, it's important to write this from scratch. Anyways, so we have done this. So now the model definition. Each of the model, the single head attention, the multi-head attention, the feed-forward network, the block, all of these things are done differently. And this is, this is a model definition. The f of x, simple terms, f of x. This is the f of x calculation. If you want to understand how it happens in PyTorch, it happens in 2 steps. First, you're calling the function. Let's say you want to define e to the power x plus y, right? So you want to call addition, you want to call x, you want to call y, you want to call exponential. So a PyTorch class of the entire neural network is done in 2 steps. First is calling these functions, because otherwise you have to define from scratch. You call x, you call not x and y, you call e to the power x, and you call addition. And in the second step, what you do, we will talk about it, is you combine these functions into a single function using PyTorch linguistic code. So these are the 2 steps in which it is done. It's very easy, okay? I didn't know Python when I came here for PhD, and if I can learn, I'm sure you can learn too. So this is how it's done, and we will talk about it. It's very simple, guys. You just need to just spend some time with it, because I heard that people are not so comfortable in coding, but I am sure where the world is going towards now, everyone should be learning coding, okay? Because even if you're doing prompt engineering and stuff, you should be learning coding, and it should be becoming essential in the next 5 years, I'm for sure. Okay, so now the next part is, this is where the training happens, the training, the optimization. And you will see we have done 5,000 iterations, that is epochs, and it is running here. You can see. It will start running now. This is the number of parameters you have. 0.2 million, you can see its step size. So you will see the next step size is it should come at 100, because there's if iteration is divisible by 100, then we are printing it, okay? So let me show you step 100. So it runs for the next 5,000 steps. So till that time, we come back to this whole discussion, and it is being performed on, I'm not sure, CPU probably. It's in Google Colab. Okay, so let's come. Yes.
Question.
Yes.
Yeah. The question is about the training. So you
Yes.
didn't explain the training. So how exactly the loss is calculated?
Yeah, I will explain that now when I discuss the code. Yeah.
Okay.
Yeah.
Okay.
Thank you for pointing it out. So now I have copy pasted the code out here. So let's see how the code is being run. So first we are reading the text data. We are reading this text file, array.txt, and we are encoding with this corresponding, whatever it is, corresponding character format. And we are saying that we are reading this text file essentially. F is the file. We are opening that file as F. Now, what is this? This is nothing but the set of vocabularies. So we are transforming the text into a set. Now, text is an ordered set, right? Let's say there's a difference between an ordered set and a set. So if you have 1, 2, 1, 3, this is the ordered set. That is how text is right now. It's transformed to a set. In a set, there is no order. 1, 2, 3. Okay. This set is same as 3, 2, 1. Right? So that's a problem. So a set is not ordered. So that's why we convert it into a list. because list is easy to do, is to do all the basic vector computations. It's very easy to do it because that's how all this vectorization happens in Python, R, or whatever, MATLAB. And then this is a unique function, sorted. This sorted is making a set into an ordered set kind of thing. So unique ordered set, you can say. So this is the set of vocabulary. Now, based on this vocabulary, it's like A, B, C, D, like this. Okay, based on this vocabulary, we are calculating the vocab size because that's important. We will see where it's important. It's because in the final output layer of softmax, the output should be of the same vocab size, right? All the probabilities should be same vocab. Like each of the vocabulary should be given a probability. That's why the vocab size is important. Now we are creating a mapping from integers to characters to integers. Say st is string to integer. So sto, like string to integer, stoi. So essentially it's making a dictionary here. Okay. So enumerate is nothing but it's a very interesting function. It's nothing but it gives both the value and the index. It kind of gives xi and I both. That's how it's made. Okay. So or rather I comma xi. So that's why you can see I comma character. That means it's I comma xi of the characters. That means I hope you understand. If the vocabulary is this enumerate is nothing but 1 comma a, 2 comma or 0 comma a, 1 comma b, 2 comma c, 3 comma d. That's how the enumerate is happening, taking in this list of the vocabulary list and replacing it by this. And this is being done and a dictionary is created. If you know Python, and the same thing is done for the, if you want to change from integer to string. And then the two functions are created, encoding function, decoding function. Encoding is nothing but we are making a function that takes in each of these characters and assigning it to a number. Decoding is taking the integer and encoding or decoding into a character. Okay, so it's a bijective function, remember. That's why inverse exists from a mathematical point of view. And so this is nothing but, this is called a lambda function. So usually when you define a function, you define def function, then you give the parameters, then colon, and then you define the function. But a lambda function is nothing but it creates a function with on the fly. It is not stored in the memory. Okay, that's why it's important. So that's why they use a lambda function. I didn't know this. I learned this recently. So previously I used to use def only. So, and you can see essentially it's nothing but for this C, it is concatenating into a list. So this is a function. So you can see that this is nothing but saving that as for each of this character, it's putting that integer out here. So this is a so you have to just understand how these things work internally. I'm not going to talk about it because it is not useful right now. Proper use of time, I would say. And here it's essentially nothing but the string is joined, each of the characters is joined one by one for all the decoding. That's how it's done. So this encoding and decoding happens on the vocabulary, and this is being for a new sorry, the encoding and decoding actually happened here, okay, in this dictionary for the vocabulary. Okay, now it is being extended to general text where you're inputting S and L. This is the basic idea. So you can see the comment is written over here. I hope all of you understood this pre-processing step. Yes or no? Give a thumbs up. Yes. Did you understand what's happening here? So essentially it's taking a text, changing all the characters to integers and vice versa. Building functions for that. All of you understood this? Like at least the logic of it, not the code, let's say, but logic of it. Yes or no? Give a thumbs up, please. Okay. You can also write comment in the comment box, yes, if you cannot give a thumbs up. Okay, thank you. So now the training that Professor Mukherjee was asking, this is important. Understand this very carefully. So there is a block size and there's a batch size. So batch size, all of you know, I've talked about it. um, and the block size. So what is happening here is you take the data set, the torch or data set. So you take the text, you by the encoding function you convert it into integers, numbers, a list of numbers. So essentially it's x1, x2, xn now, where xi's are numbers. I would say xi are the so if you observe, the xi's are nothing but the index of the numbers, okay? Index of the characters. Now it's transformed into a tensor. Now this tensor is very important. Tensor, why? Because in deep learning, in GPU, each of the input is of the size, batch size is there, and then time length, and then C, the channels, the dimensions. So this is the time, this is the batch size, this is the channel dimension. In as of now, the batch size is 16, time dimension it's in 32, and the channel dimension is 1 because one integer is there, 1. Now n is nothing but the training set. First 90% is training set, and the next 90%, 10% is a test validation set. This is how it's done. So the train test split and block size and batch size is clear, guys. The definition. Yes or no? Give a thumbs up. Yes, no, maybe. Did you understand? This should be done step by step. All of you understood this? Any question? Okay. Yeah, I need this regular interaction. Otherwise, it's hard for me to understand where to stop. So I'm stopping at small breaks so that if you cannot understand, it's not too late. Okay. Okay. So now we will understand how this batching is done. And this is how, so this batching is nothing but how one epoch is being calculated. So based on the split, the training test data set, this is how the batch is done. Understand this. So you take the data set, the training data set, the train data, if the split is train, and else validation data set. Now what you are doing is, then you are taking the ID, the index. Remember, those numbers are the index of the characters, not some value of the character, but the index of the characters. So we are using the index of the characters here. So what we are doing is this. What exactly it is doing? This IDX is choosing, understand this very carefully. Its IDX is choosing 32 block sizes. So the index over the entire data set. So let's say the entire data set length is 16, or let's say 6, x1, x2, x3, x4, x5, x6. So it's changing, it's calculating the length of the data set, 6, subtracting the block size, because it needs to do like this, right? So if you want 4, it needs to do like this, right? You understand? If it needs 4, it needs to do like this. It can only access 3 of them, right? That's why the minus block size is there. So it's calculating the length minus, so it's calculating this 3, this is the 3, and taking a random integer out of it, which is and 32 of them, batch size of them. Okay. Now, how is the x and y selected? The x is selected, let's say index 1 is selected, then the x is x1, x2, or 1, 2, 3, 4. And the corresponding y should be what? Any guess? It should be 2, 3, 4, 5, right? Just like we explained here. 1, 2, 3, 4, or 2, 3, 4, 5 for this connection. So that's why the x and y are correspondingly selected. like this. All of you understood this? And then we are changed to device. Device is for the queued up calculation. Let me just check if is the training over. Just give me a minute. If you have doubts, please formulate a doubt. I will come back. Just give me a minute. Yeah. So yeah, this seems like the training is over. Okay. So again, coming back here, let's say the entire data length is 1 million. The block size is 16. Sorry, batch size is 16. So what is done is that from 1 million, the block size, the last 32 are being taken off, right? Last 32 elements are taken off. So it is now 1 million minus 36 number of indices. The first 1 million number of minus 36 number of indices. From that, random 16 element, x are taken. Random 16 x are taken. 16 x 16 such blocks are taken. The initial indices, because that's initial, from the initial index only you can get the entire x and the entire y, right? If you get index, let's say 5, you know that for that index you will get the x is 5 6 7 8 and y is 6 7 8 9, right? So therefore it's just taking out random by a ran dint. So this is nothing but randomly taking out a batch size number of like 16 random integers from that random indices from that 1 million minus 36 initial indices. So it's done randomly here for each batch, and then it is trained. Okay, so and the x and y are selected. So this is, so 36 batches are sorry, this length of the batch size 32 16 is made in such a way, a sequence of x, a sequence of y. Any doubt in this, guys? Any question? Any question? Did you understand? Yes or no? Yeah.
1 million minus 36. It should be 32.
32, sorry. Yes. 32 is the block size. Any question? Did you understand? Yes or no? This is how 32 16 batch size are selected. Batches are selected. 16 batches of x and y are selected. And over each batch, the gradient will be computed, right? That's how loss is calculated. Yeah.
Stochastically. So it's a mini batch.
It's a mini batch. Yeah, absolutely. So what we are doing is that for each of this x, the f of x, the output is nothing but the probabilities of vocabulary, and that is being computed, and it's averaged out. And the masking is done. That is important. That full length, context length. Did you understand? Give a thumbs up if you have. Yes or no? Or you can write yes in the comment box. Any question? Please feel free to ask me questions. Any question? Any doubt? Okay. Yeah, sure. Please. Yeah. Anisha, can you please unmute yourself? I would like to know if where you are facing an issue.
Yes, sir.
Yeah.
Sir, please explain one more time that is that line rand int length data minus block size.
Sure. So do you understand? Did you understand what is a block size? What is a block?
Yes, sir. Yes, sir. Block size and what is the block?
So let's say you have the data set of length x1, x2, x100. Okay. Now, ideally, let's say a context like block size is this. So if this is the x, this is the y corresponding. Right? Now, how is this selected? You see that if you just select one index, let's say you select here, for that, the next 4 size will be the x and this will be the y, right? So if this is x3 and x4, x5, x3, x4, x5, x6 will be the x and x4, because for x3 you will be predicting this, for x2, x4 you will be predicting this, for x3, x4, x5 you will be predicting this, and for x2, x4, x5, x6 you will be predicting this, and this will be the y. Because I've discussed it before, I'm not sure if you were there present or not. So therefore, now understand, since you will be taking this block size, you cannot select x100, right? Because there is no future word character out here. So you would make sure that last one possible should be such that this is the last block. So that is a reason. So therefore, if there are 100 and if 4 is allowed, the last will be 96, 97, 97, 98, 99, 100, right? So this should be the 97. So that's why the block size should be subtracted. I mean, rather block size plus 1, therefore, sorry. Yeah, block size should be subtracted. Because in Python, it doesn't take the last one. It take the before one. So therefore, block size. Yeah, you just can see out there what's happening, the mathematics out there. But essentially, it's subtracted so that if you select the last one, the 4 length is inside. The last element of the 4 length context is inside that x100. It doesn't go outside. Okay. Now, there are many other different ways of doing this. This is a random way of doing this, randomly selecting stuff. In other ways, what they are doing is something called padding. So what they do is they add 0 out here and then randomly select parts. So they add 0, 0, 0 out here, just like it's done in image processing, right? A 0 padding, let's say. So they also do this. But I think, I mean, it is I prefer it this way. Okay. So the padding is done in this way. In another way, in this case, we are doing it so that the indices the last element doesn't go outside the limit. Did you understand, Anisha, why it's done? Now, randomly, certain indices are selected. For each of the indices, there is one x and one y. If 3 is selected, then the x is x3, x4, x5, x6. And the y is corresponding, because for x3 we are predicting x4, for x3, x4 we are predicting x5, for x3, x4, x5 we are predicting x6, and for x3, x4, x5, x6 we are predicting x7. This is how it's done. Anisha, did you understand?
Yes, sir.
Any follow-up question or doubt?
No, sir.
Okay. So what about others, guys? Did you understand? Any question? Any doubt? Okay, if you understood, give a thumbs up or write yes in the comment box, please. Okay, thank you, Aisha. Thank you, Srimanto, Srijit, Anisha. What about others? If you don't understand anyone, please feel free to tell me, guys. Because I would like to explain it to you. Okay. So this is the whole training process, and then the final training, but the model is explained in this case. I'm not going to the model right now, assuming you have been trained enough in that. I will be talking about it a bit though. towards the end. So now, and the inference though. Now coming back to the maximum iterations, this is the number of epochs. The evaluation interval is nothing but we are printing the loss function at 100 intervals each. The learning rate, you know already, learning rate is nothing but the step size kind of thing. The device is, this is for whether you're using a GPU or not. Evaluation iterations is nothing but for the estimate function. So when you're calculating the loss, so yes, their batch sizes of 32, right? Their batch sizes of 32, but what is done is that after, so those 32 batch, sorry, their batch size is of 16. So the 16 batch size are those random 16 integers. So there's 200 evaluations happening, of 200 batches are selected, right? And then the loss is taken, the predicted loss, the output loss is shown as the mean of those losses of those 32 of this 200 batches, the average of the batches, average loss of the batches. So this is what the loss prediction, like what you are seeing the loss, right? This is how the loss is estimated, and these are all empirical. There are many other different ways of doing that. So this is one way. The basic idea is that if you're taking random integers, it's expected if you do it for a long enough time, you will cover the entire text, right? That's it. So that's the basic idea. It's expected that you will cover the entire text if you do it longer. That's why 5,000 evaluations are done. So this is the expected stuff, and you can increase the block size, you can increase the number of iterations to play around with it. Those are hyperparameters, you know that. Yeah, so I'm not explaining all these things in stuff in details, but the basic idea that is done here is those 200 evaluations are done. In each of the evaluations, 16 batch sizes are selected. 16 batches of X and Y are selected. The loss is calculated. The gradient is calculated. The loss goes backward. The parameters updates, and again the new loss is calculated. And this way, the average of those 200 evaluations of 16 batches, after that, the final loss is averaged over all of them. So that's how the loss is calculated, and based on that loss only we are stopping, right? Because so that's an important thing to know how it's done. Okay, so this is the model class. I will talk about it, but let's talk about the training part. So the training, the model is called, the model is named, the number of parameters is printed, the optimizer is taken to be Adam optimizer. There are different optimizers. Now, why different optimizers? Because if you remember, this is a basic thing when you are doing optimization gradient descent. Let's say you have a gradient very slow here. It's a slow gradient, right? So what is done is that now there's a fast gradient here. Now this is the global minima. So you want to move fast. Now when it's a slow slope, you want to move faster. And if it's a high slope, you want to move slowly so that you do not miss it, right? If you move slow here, it will take a lot of time. You want to move fast here where the slope is slow. Where the rate of change is low. You want to move faster there. And where it's very high, the rate of change, the double derivative, you want to move slowly so that you do not, if you want to move fast here, you may miss the local minima. So therefore, the learning rate in the gradient descent should be adjusted based on how the curvature of the curve. Now, curvature is nothing but proportional to the double derivative, right? So that's all done by the Adam optimizer or similar to optimizers. Now, for iteration, in the maximum iteration, there's a number of epochs. If the iteration is divisible by 100, we print the iterations, the losses of the training and losses of validation. and this loss is nothing but called from the estimate loss function. Okay. Now I have talked about it again. I have talked about before that this estimate loss is very important in the sense that there are certain layers out there which should stay the same and that have the ability to change if it's called different times, like dropout layer. So it should be made sure that it doesn't change while you're evaluating, while you are inferring. That's why that kind of different loss function is, the different function is written, which is not usually done without drop out. Now you are getting a batch, right? You're evaluating a loss. So you're evaluating a loss batch by batch. But for getting the final loss, you're taking average of the losses after each of every batch, 200, right? And that's what you're how you're calculating, right? So how the model, like how the generation, the model inference is done. So I have talked about in the same way. So let's say the maximum, what is a token? Token is nothing but kind of, you can say, the minimum possible. Each token is nothing but the smallest atom, the smallest possible thing that can happen. In this case, it's character. So max new tokens is that the number of characters you will generate, right? So if something, it's a variable, if it's taking in the range of the characters, the number of maximum tokens, it's taking that, let's say 2000 in this case. Now what it's done is that this is important. So as I have told you, the block size is important. So it's just making sure you're cropping to the block size of the token, right? You're cropping to that. Now there are two columns because the first dimension is the batch size, the second dimension is the time, the token, the time array, right? So it's just taken the first block size, and based on that first block, and based on that the logits are calculated. The loss is not required here. Logits are calculated, and based on the logits, the final output is taken, right? The final output is taken, and we apply the softmax on that to get the best possible index, the index with the highest probability. And we get that ID, right? And we attach it to the initial index. So BT was the input like the batch size comma token. So now when you're inputting a new one, your batch size is 1, right? You're giving one input of batch size. One input of batch size. So when you see generate, you will see you are generating one input. The first dimension always be 1. When you're giving a new for your evaluate or inferring it, the batch size will always be 1 because you're giving one data set. So, and the output will be, so you give first 5 characters, so it will be 1, 5. Let's say you get SATY, okay, then output will be A, right? Or SATA, output will be J. So this is the input, and SATY, the numbers for it, let's say, and the output will be J, which will be, or the predicted output, whatever it is, it will be appended, right, to SATYAJ, and it will become, so let's say 5 is here, so it will become T plus 1, that is 6, 1, 6 after the J input. Now again, this is running for maximum number of tokens. Let's say it's trying 2000 tokens, 2000 next characters, right? So it will keep on doing this, keep on predicting, appending it, predicting, appending it, predicting, appending it. And the last block size is taken. Last block size is taken for prediction, because minus of block size is given here. You can see minus means the last block size, and that's given for prediction. And this is how the generation model inference is happening. Here you're giving an input prompt. Here it's taken 0, 0, 1, 0. 1, 0 means the value is 0, the size is 1, 1. And For input 0, it's trying to predict the next tokens, the 2,000 characters, and those are numbers. So therefore, they are decoding it after the number generation into characters to see what's happening. Okay. So did you understand the inference part, guys? Yes or no? I explained it without code. I'm explaining it with code now. So did you understand? Yes or no? Give a thumbs up if you understood.
Sir, can you explain the inferencing part one more?
Which part? Tell me, Aisha.
Sir, the after the logics part, sir.
So logics is without the probability. Then softmax is taken. I hope you know softmax, right, Aisha?
Yes, sir. Yes, sir.
Yeah. Tell me what you didn't understand. So the softmax is taken. We get the set of probabilities for the vocabulary size is V. Let's say it should be V here. So it's C is taken for the channel, whatever the channel dimension. It is V here. So V probability is output. For that, the maximum probability is taken here. Okay. This is actually calculating the maximum. It can be also done in the some different way. But this is interesting. This is nothing but there's a multinomial. It's like it's so X is following different probabilities. So it's taking multinomial here, not taking the maximum probability. So this is different. But you can also take maximum probability, the index of the maximum probability. So what it's done is fun. So let's say the distribution here, the probabilities, let's say you get 0.2, 0.1, 0.2, 0.3. So 5, 0.2, let's say. This is a probability. Okay. Now, why it's multinomial taken? Because two characters can have the same probability, right? Or similar probability. So which to take max of? So what is done is that X, so you can probabilistically represent a random variable with the corresponding multinomial probabilities. The multinomial is done because on expected, the average value of this will be the maximum probability. You can prove that, right? If you do it, if you kind of understand by law of large numbers that on average it will be the maximum thing only, maximum probability only. But the question is that what will happen if it has multiple maximums? And that's where this multinomial is used. That I'm not sure all of you know about multinomial or not, but I assuming you know multinomial distribution is like an extension of binomial distribution. So it's just done to bypass that if two of them has similar probabilities of maximum or more, two or more, then what to do? So it's done in proportional to the probability. That's it. If someone is higher probability, so essentially what it means is that what this means in experimentally, it's called the frequentist way of understanding probability, is that if you sample this random variable 100 times, 20 times you will get the first one, 10 times you will get on average, 10 times you will get the second one, 20 times you will get the third one, 30 times you will get the fourth one, and the 20 times you will get the fifth one, right? So on average, these are coming out. So now these have equal probability. So what to do? So did you understand, Aisha, now? I'm not sure.
Yes, sir.
Did you?
Yes.
Okay. Any other question? Did you understand the whole idea? All of you, give a thumbs up if you have. No one understood? Yeah, any question?
Your training batch size is different than the inference batch size, isn't it?
Where is that?
No, I mean, while training, you have taken batch size as 16.
Yeah.
But during inference, it's a character by character inferencing. So it's
No.
one. Really.
No, yeah, I mean, for inference, batch size is not important, right? Because there is no loss training. Batch size is done for gradient descent. Or
Yeah. Okay.
so for evaluation purposes, you just need one input for evaluation. Like batch size is 1 means you're giving one data, and for that one data, one X, you want to have one Y. So if you want to have 5 different people having 5 different prompts, then you will have batch size 5. Or if you want to train the same model, let's say from 2 different systems you're typing, it's kind of parallel that's the whole idea. Parallel competition is very important here. So if you want to have 2 batch sizes happening, then you give the same model, the same different prompts, that will be 2 different batch sizes. But but essentially we want give from one prompt and one output, so that's why batch size is 1. Any other question? Is it clear, Professor Mukherjee?
Yes. Yes.
Okay. Any other question? Do you want me to explain any of this again? So yeah, this is the entire explanation of the entire thing. Okay, let me now show you the output. Now let me just show you some fun stuff. So this is the training is done. All of you can see this, guys? All of you can see? So the training is done, and we get the validation loss to be 1.9. It's kind of close enough. Now we want to use inference. We give, sorry, it should be. And it's giving the output. We give 2 zeros, 3 zeros, and it's corresponding to that, it's giving the output. 2000 next 2000 predicted characters. So okay, this is Bengali, but if you know that it can it can understand what is Feluda, it can understand it's kind of fun that it has learned certain grammar, but it doesn't make sense. But individually, it sometimes makes sense, which is interesting. So this is to show you that it can handle any language. So yeah. But yeah, everything is not correct. You have to train longer, or you have to give, let's say, I don't know. Okay, so this is one. Let me just show you an English one. So let's do the Constitution of India, COI. So I will do COI. Trend. It will take some time now. Again. It should take some time, but yeah, this is kind of fun. Any questions till this point of time? So whatever you do, the context, that context is nothing but a prompt. Okay, you can give your own context out there. So if you want to write Feluda, or if you let's do something else, so we'll understand. So coming back in the last few minutes while it trains, let me come back to this and show you and teach you how to actually build a model. Okay, so before I go here, I want to show you this, that I have written an entire tutorial for you to refer to after I know it couldn't have been completed, so I have written an entire tutorial a week or two back of how each and every part is being calculated, what is the meaning of each and every part, and everything, whatever I've talked about, more than that is written here. And it also teaches you how to build, like, what is the optimum way to build the architecture. Okay, so let me talk about how to build the architecture from scratch while it trains. So if you observe this, so what are the parts of this architecture? There's a multi-head attention, there's a transformer block, and there's an output block. Now, if you observe multi-attention, there are parallel multi-attention happening. You can see the parallel thing. So what we need to do is that we need to have those are the number of heads that we said, the multi-head. The number of parallel things are heads. So we want to calculate one single head, like one linear, then QKV, then matrix multiplication, then masked attention, then softmax dropout, matrix multiplication. That is happening parallel number of heads for that number of thing, and that should be concatenated. So we want one class, one function to capture that one single head, right? One function to capture the entire multi-head. Now this multi-head is inside this whole transformer block. So one function for the transformer block and one function for this entire block. So 4 basic classes should be calculated, as you can see. Single head attention block, multi-head attention block, the transformer block, and the GPT model, final model, aggregating all those things. So if you observe so now what the good thing I have done here is that I have given all the individual dimensions out here. Now, one important thing you should understand how the singular attention is created is that this before, let me go to the first GPT layer. So in this GPT layer, in this GPT module, GPT-2, this is the GPT-2 architecture, okay? So there are two things. You must be knowing that in GPT and transformer flow, there is a embedding and a positional embedding and normal embedding. So what is done here is this, that you see each of these indices, those are randomly transformed by a linear layer. So this nn.embedding is nothing but a pre-saved linear layer, okay? This is a pre-saved linear layer. Now what it is doing is that for an input character, it has an index, right? Let's say A has index 0. For that index 0, what it is doing is that that character is being linearly transformed to this input dimension of, let's say, the input dimension is, let's say, 64. So that A is being transformed to a vector, random vector that you do not know, that is being saved in this nn.dimension, nn.embedding function that comes on the nn.module library to a r to the power 64, the 64 length vector. And each of those characters is being transformed to this 64 length vector. And it's a batch size of B, the time length T, which is the context window initially, and E is the embedded dimension. Similarly, positional embedding, but in understand the positional embedding, we should only have information about the context length, the 16 or the 32 position, like each of those locations, right? Those should be incorporated. That's why it should take those 1, 2, 3, 4, 5, 6, 32, each one, the first one to a 64 length dimension, second one to a 64, the numbers, okay? And those are added, as you know, in the architecture that happens. I assume that you know a bit about the architecture because it is already taught. I just show an use case of this. So there's an input, it transforms into embedding dimension, and a positional dimension that are added, right? And then it goes through each of these blocks. First it goes through. So now, so as I've told you, in PyTorch, you first define those functions, right? Either you define the functions before, as we have done, or you call like this nn.layer. Whenever there is nn, you're calling from the nn module. And whenever there is no nn like this, I have already defined before. And this is the definition of the functions, and these are the application of the functions. So you first define f1, f2, f3, f4, f5. Then you do x1 is equal to f1 of x. x2 is equal to f2 of x1, like this, in a composition, because neural network is nothing but compositions of functions, right? So these are compositions. And all the corresponding channels, the output channel size and batch size are written. And I have done that for you, and in a tutorial, in this tutorial, and you can run this on Google Colab and see that output is coming out to be this. So 91 is a vocabulary size here. So after one epoch or one that, whatever the model output is this. 8 is the context length. and 91 is the vocabulary size, right? Because for each context length, if you remember, for each of one of them is a y, right? If you remember, x2, x3, x4, x5, for that the output is x3, x4, x4, x5, x3, x4, x5, x6. So the x3 is the y, you should have the y hat. So there should be the context length of output. Now each of those places should have a vocabulary probabilities over all the vocabulary elements, right? And that is a 91 element, and for each batch it's happening. So 32 cross 8 cross 91. I hope there is more time to discuss about it. I know there is a lack of time, but if you read this you will understand it better, and that's why it's made like this. It's almost over the training. Yeah, so this is what I want to talk about, like how to build your architecture, is to look at the architecture, see which part is being repeated over and over again. It's kind of a for loop. When you know that, oh, this thing is done over and over again, you do a for loop, and between that for loop you define a function. So the for loop is a function, and inside that for loop there is another function, recursion, right? So that's exactly what is done. So you see your architecture, think about it, what are repeated over and over again, and then define your classes. And based on those, these classes are defined. First is the single head attention class, the multi-head attention class, the transformer block, and the GPT model finally. And based on that, the entire thing is done. Simple stuff. And I would suggest that instead of running the entire model, you can just see whether your model is running whether the dimensions, because if you want to make your own architecture, you must make sure the dimensions are fine. And the way to do that is to make sure that you put an input dimension which is in align with batch size and everything, and the output dimension is what you expect. Okay, so this dimension matching, I would say this is linear algebra at its best. Like rather, I would say matrices and tensors at its best. So you must make sure this is the only part that is very important. You must make sure that this is in aligned what you expect. Before you make an entire model, just run this basic thing out there to see whether dimensions match or not. That's it. That's how we will know that your model will work perfectly. Okay, so you can read this. Let's see how much is left. Yeah, I think it's almost done. Yeah. Now you can see. So I'm putting 000 AAA probably. It's evaluating. So yeah. So you can see A is a random input, right? For this, the whatever the output is, but you can see it got the word constitution, got the president, government. This doesn't make sense. This doesn't make sense. Probably just it wanted to make just, but it got T because S and T are closed. Probably it missed by that. It should be provided and there is prohibited. Probably they mixed it. It got some numbers correct. Yeah, so it's fine. It's makes sense, certain things, right? And you can see the spaces are coming up. The spaces are coming up out here. So yeah, so what I want you to is that I will give you this code. You can run it because I have not added anything. What you can do is this, that you can go here. So this is the character, right? Now what you have seen is that you have got, let's say, print text. So this is the text, right? The entire constitution. Oh my god, it's big. It should be big. Just give me a minute. So let's do the first 100. Yeah. Let's do the first 1,000 characters. So you can see. So, so you see the name Dr. Risha Vashishta. She is the current Legislative Secretary of Government of India. So, yeah, probably her duty is to write this and upload this online. So that's where I have got it. So this is the input. So now what you can do is that you can see the vocabulary of constitution. Let's say you want to input the word constitution out there. So you want to see that encode the word constitution. Let's say X print X. So this is the number for C, it's 27 index. For O is this. Now you want to convert this into a torch. Okay, so let me just write it down. Just give me a minute. I forgot the code of how to convert this into a torch. Convert list to torch. I'm searching in ChatGPT. Okay, torch or tensor. So let's say X is equal to torch dot tensor of X. Now print X. So you get this tensor. Now remember, this is of, if you see X dot shape. So you will see it's torch of size. So you want to increase the diamond because batch, you want to append the batch size, right? Increase the diamond with the batch size, right? That is important. So let's say X dot unsqueeze in dimension is equal to 0. So print X dot. So yeah, now it's 1,12. Now what we will do is that we will input it here. We'll see what it gives. So we are inputting the word. Sorry. So we are inputting the word constitution and want to see the output. We are giving the prompt constitution and want to see the output, what's happening. That's how you can test it out. Yeah, I think this is all about it. Yeah. So now you see that it inputs the word constitution. That's the first word, and the more characters are added to it after that. You see the point, all of you. So after that, each of the 2000 characters are appended after that. Doesn't make sense anything at all, but it's something interesting. So yeah, this is how a ChatGPT model is trained on a large scale. Yeah, that's all about it. So okay, by the way, I want to talk about a few things. So I want to give you some references. First of all, this entire code is done by Andrej Karpathy. So he is the mastermind. So he first developed this entire set of codes, and next he has a YouTube channel. So feel free to go to his YouTube channel. And he is, I would say, he is the best educator of the. He has actually, who was in OpenAI before he developed the whole self-driving car at Tesla. He developed the ChatGPT thing at OpenAI, and then he is now sitting at his home building educational materials. He's the ideal person, and he's a very good person at heart. For learning, I would. So Sebastian Rashka was a statistics professor at University of Wisconsin-Madison. He got out of statistics department, built his own company of Lightning AI, where you see PyTorch is a lot of other nuances. So he has built PyTorch lighting.ai, where it's kind of a wrapper around PyTorch to make things easier for non-machine learning people to build models. That's it. So yeah, I would suggest this Andrej Karpathy's book, Andrej Karpathy's YouTube channel, and Sebastian Rachka's book, Build a Large Language Model from Scratch. And of course, my tutorial. I will share the PDF of this presentation after to Professor Mukherjee, and he can share it to the students. Yeah, that's all about it. And I hope you enjoyed and you learned something valuable out of it.
That's fantastic, Srijit. Any questions? I know that it's very interactive and educative for all of us. But participants, if there is any question. So if you, Srijit, if you share those link and also I can, maybe after the talk, I mean, you take your time, then I can share it with this.
Absolutely, I will share all the codes and everything out there. So.
Right.
Any question, guys?
Any question?
Is there any way I can help you? Do you need more resources? Any question?
I can see that there are a lot of questions in between and you force them to learn. So therefore, I think, yeah, the message is conveyed successfully. So if not, actually, let's thank the speaker. And how can I thank the speaker? Oh, there is an icon there. So why not all of us send this thank icon? I mean, it's really very informative and we really liked your talk.
Thank you.
And maybe some of the students will email you. So
Yeah.
Sujit, a graduate student of Penn State University. And I know that it's almost approaching his lunchtime, right? So
Actually, I was making this whole PPT from 2 a.m. in the morning. So
2
it's
a.m. Oh my God. Yeah, I know how serious you are. So thank you once again.
Sure.
And
Thank you,
once
Aisha.
again, on behalf of the Computer Society of India, I would like to thank you for giving the time and your interest, right? And your excellent talk, excellent tutorial talk. And we'll see you sometime once again. Okay?
Sure.
Thank you. Bye-bye.
Bye. Bye.
I'd like to thank the participants as well.
Sir, one question.
Yep.
Yes.
Sir, regarding that, if we want to train a model on some documentations and we want to extract, so if we want to build an application that serves that we all go through documentations for building different tools. So if we can, instead of going through the whole documentation, if we can just like the ChatGPT, but for the particular documentation of that tool only. So if we can do,
Yeah,
for
you
that,
want easier question how to build that?
yes, sir, the pathway or the workflow, sir.
Okay, so that is a different thing. So you cannot train from scratch because if you see the whole server of OpenAI and these things, these are big. This is bigger than one building of Penn State. Okay.
No, sir, not training from scratch, but
Yeah.
kind of inferencing and.
Yeah. So let me explain. So that is called fine tuning. So I think I can do another talk if I do not know. But essentially, you have to step one is you have to go to Hugging Face. You have to call the model Llama 3, the recent model, open source. Download that and then train it on your dataset or local GPU. It will take one GPU. I can give another training on that, or maybe I will build a video on that. Yeah. So and then give your whole document.
So what you are
just use-
suggesting is take a pre-trained model
Yes.
and then fine-tune it on the local data set that each
Yeah.
of us has in our own domain. Right?
Yes, I think that's the way out. Yes.
Yeah, I mean that's what we usually do. I think.
Yeah. Thank you for the question, though. That is important. That is one of the. I think I initially thought of doing that, but I thought this was more basic and fundamental than doing that.
No, this is fine. I think. Yeah, this is a baby step. That's fine.
Yeah. Thank you all the participants for joining.
Thank you. Thank you very much.
Yeah.
Thank you once
Thank
again.
you, sir. Thank you, sir.
Yeah.
Thank you.
Oh, just 1 minute. I will share my LinkedIn ID. So do not email me. Just send me on LinkedIn so that I will share it in the chat box. Just send me that you. Yeah. Just send with a note that you have attended this workshop and you would like to, so that I know that you are there. Yeah, I have sent it in the chat box. Yeah.
Yeah, you know the context. Yes.
Yeah. Sure. Thank you.
Thank you. Okay. Yeah. Sorry that we couldn't offer you lunch. So.
No. Sure.
Yeah. Okay. Bye. Bye, everybody.
Bye.
Thank you.
Thank you.